In this tutorial, we will create a tower inspired by Cytokinesi Tower by Hayri Atak Architectural Design Studio. I started with circle and plug number slider into radius input. This gives me the base curve to start with. Next, place this circle in different levels. To do that, move it with series of z vectors. I use component called series to create a series of numbers, then connect to vector z. For step value, set it to floor height of the building. For count, set how many floor you need. Next goal is to scale these circles at their center to get the overall form looks like this. Each circle need to have their own scale value, so first we create a range of numbers between 0 and 1 using range component. As you see here, the list length of range component is greater than by 1. At expression x minus 1 to match the list length. If we leave by default, the last circle will be duplicated. Next, remap these values using Graph Mapper. In this case, the maximum output of the Graph Mapper is 0 to 1, so we need to remap to the new domain using remap numbers component. The new domain will be 1 to 1.63. Next goal is to split these curves at these points. To visualize these splitting point, I use evaluate curve component. We parameterize to make the curve domain 0 to 1. Now copy and paste the previous Graph Mapper setup and connect to evaluate curve. In this case, we can control the overall shape of these points using the Graph Mapper. The next goal is to shift these points. To do that, copy and paste the previous Graph Mapper setup, then add them together using addition. This will increase the parameters according to the second Graph Mapper. To offset in another direction, use subtraction. Merge these together and graft both inputs. This will make 45 branches and 2 items in each. This means 2 parameters match to 1 curve. Graphs to match the branches. Now shift these curves to the half side of the circles. When we reparameterize the curve, its domain becomes 0 to 1. By add 0.5 to each parameter, it will shift to half of the circle. Here we have one warning. Parameter is outside of the curve domain. Results may be unpredictable. This means some parameters less than 0 or greater than 1. These negative values and some possible result that may be happen at greater than 1. To fix this, we use this expression. This means if x is between 0 and 1, we take x without modifying it, else we take the absolute value of 1 minus absolute value of x. Now split the curves at this point. To do that, use the shatter component and the same parameter as evaluate curve. Here the order of the segment is not as expected. By using sort along curve component, we can sort the middle point of each curve. By using the sort point index, we can reorder the curve segments. The sorting curve will be the circle we created before. Using call index component, remove the curves that have index numbers 0 and 2. Now we have 45 branches and 2 items in each. By using flip matrix, we can flip into 2 branches and 45 items in each. Now we can create a loft in each branch separately. Mesh Loft from Chromodoris plugin. It works on polyline, so rebuild the curve with a degree of 1. To make panel and frame, use Weaverbirds picture frame and mesh window component. For inset type, set it to 1, that mean parallelogram rule. Next, we are going to create the connection pipe between these two forms. First, create a line between start and end point of each segments, then loft them. Now go to Rhino and draw cross-section curves. You can also make these lines directly in Grasshopper by populating point on the surface and create a line. Reference those curves in Grasshopper. Create perpendicular frame at start and end point each curve. Graft the curve input. This makes two parameter match to one curve. This will create two planes in one curve. Next, create polygon on each plane and create a loft. Using split prep multiple components, split the first surface with these pipes and the vice versa. Using list item, chose the separated surfaces and join them using prep join component. To smooth the connection edges, first we convert this prep to mesh using quad remesher. Here some gaps are created. Increase face count to fix this. Smooth the mesh using Weaverbirds left place smoothing. To keep the edge from collapse, set 0 for S input. Here I don't want the overall form to be modified, so I will separate the mesh faces the close to these pipes and smooth separately. Mesh explode to get each mesh face separately. Using pull point component, pull the center of each face to the closed geometry, in this case these pipes. Using cull pattern, we can separate the meshes that have smaller distance value. Now join these faces using Weaverbirds join and weld component. Invert the pattern to get invert selection of faces, and join to the smoothed mesh. Next we are going to make triangular pattern on this mesh. Remesh using tri-remesh component and create panel and frame on dual output of it. Add additional level of smoothing. Next, create floors. Offset the mesh to create gap between floors and panels. Convert the mesh to sub D to remove jagged edge that may created liner. By using prep plane intersection, we can get boundary edge for our floors. Create XY plane at the center of each circles. By using these plane, we can get the intersection curves. Offset the circles to create gaps between panels and floors. Here the intersection curve is short, this cased from the sub D edge. To get sharp edge, check corner at mesh corner option. Pull these intersection curve to these circles. With this we trim out the curve region outside the circle. Split the circles with the sub Ds and reorder this segment like in the previous. Here the sub-Ds failed to split some curves, so increase the offset value to fix this. Now merge these curves. Simplify to match dated tree, then create boundary surface. Give thickness to the floors using offset surface from Pufferfish. Thanks for watching. See you in the next video.